Hey everyone, it's that math magician, and on this video we're going to learn a shortcut for solving sides for a right triangle, and more specifically for a 30, 60, 90 right triangle. So let's go ahead and get right into this video and discover what that shortcut is and how we can use it to solve for some sides. So here we have an example of a right triangle, and we call this a 30, 60, 90 degree triangle because the angles inside are literally 30 degrees, 60 degrees, and that 90 degree right angle. Now, hopefully we're a little familiar at this point with sine, cosine, and tangent, and hopefully we feel a little familiar with how to use those to solve for unknown sides. And they work great. We use them all the time, and they're a great tool to know and how to use them. But sometimes you'll come across a 30, 60, 90 triangle which actually has some special characteristics and properties that will allow us to solve for unknown sides a lot faster. And so in this video, I want to explain to you what those are and then show you how we can use them to actually solve problems without sine, without cosine, and without tangent. So if we have a right triangle here, a 30, 60, 90 triangle, we notice that we have this short leg here, we have the long leg here, and then we have our hypotenuse. Now the short leg will always be across from the 30 degree angle, since the 30 degree angle is the smallest angle. So the smallest angle will open up to the shortest side. Let's go ahead and label this shortest side here X. And then we notice that 60 is going to open up to our longest side, and we have our hypotenuse, which our 90 degree angle opens up to. Now, one great property of a 30, 60, 90 right triangle is that the short leg and the hypotenuse, they actually have a relationship. And that relationship is that if you take the short side of a 30, 60, 90 right triangle and you double it, you will end up with your hypotenuse. So no matter what your short leg is, you can find out the hypotenuse just by taking that number and multiplying it by 2. Again, this only works for a 30, 60, 90 right triangle, but you will see that that relationship will always appear for this specific triangle. Now we can also find the other leg, the long leg on this right triangle, and this side also has a relationship with the short side as well. And that is that if I want to find out what that long leg is, I take the short leg here, X, and all we have to do is take that side and multiply it by the square root of 3. Again, no matter what that short side is, you take it, you multiply it by root 3, and you will end up with that long side of your right triangle. That is the shortcut. Okay, that is the shortcut for helping us solve these triangles and not needing to show a bunch of work for that. Now let me show you how we can use this very quickly to solve for some unknown sides of a right triangle. I'm going to go ahead and take this triangle and I'm going to copy it over here to the right so I can use it for this example. So let's say I have this right triangle here, and let's say that I know that this side over here, my short side, let's say I know that that side is 7. And the question asks you to solve for the missing hypotenuse, which is y, and to solve for the missing long leg here, which is x. So you could, of course, try to use sine, cosine, tangent on this problem. Oops, I did forget one thing. We have to add that this is a 30, 60, 90 triangle. And once I have those angles, I could definitely do sine, cosine, or tangent, right? I could use my 30 degrees here. I could use 7 as the opposite side. I know that y here is my hypotenuse. I could definitely just create a sine problem and solve for y. But now there's no need to do that because we have this shortcut on the left, which is a 30, 60, 90 right triangle. What that tells us is that since I know that my short side here, or my short leg, is 7, to find out my hypotenuse, I just need to take that short side and multiply it by 2. So I'm going to take the fact that this side is 7, I'm going to multiply it by 2, and now I automatically know that my hypotenuse there equals 14 without having to do sine to prove that. And if you don't believe me, set up a sine ratio and solve it, and I'm sure that for y you will end up with 14 as that side. Same thing can be said about that x variable. We want to solve for that side. We're going to use our shortcut. Our shortcut says in order to find that side, just take your short side, multiply it by root 3. So if I do that, I will end up with 7 times the square root of 3, and that's it. We have solved for those missing sides by using that shortcut for a 30, 60, 90 triangle. That's it. There's no work required. You do not need to get the decimal for 7 root 3. You leave it in radical form, and that's all you have to do. Now again, you could always use sine, cosine, and tangent to solve for those sides, but it's truly not needed when you know this shortcut and you remember when and how to use it. It's that Math Magician, and I'll see you on the next video.